A calm day in 1958. In the evening of July 9, 1958, it was relatively quiet in the scenic Lituya Bay. It was 10:15 p.m., and despite how late it was still about an hour before the sun would set. Suddenly, all of the animals in the bay were jolted by the motion of a large magnitude earthquake. 36 miles to the southeast, a section of the Fairweather Fault slipped, generating a magnitude 7.8 earthquake. 7.8 earthquake. All of a sudden, an incredibly loud boom was heard, originating from the northeast. Unexpectedly, large fragments of a glacier were lifted upwards by several hundred feet, being carried by a wave with a height that was seemingly impossible. A megatsunami forms. A megatsunami had just been generated, which peaked in height at 524 meters or 1,720 feet and seemingly towered over much of the bay. As this massive wave flowed further from its source, it remained tall but quickly lost its height. At 2 miles distant, the wave reached a height of 94 meters, while at twice this distance the wave peaked at 37 meters. Large swaths of land were flooded along the way, causing the water to even reach a lake 3,500 feet from the shoreline. What had just occurred was the tallest tsunami ever recorded, which destroyed millions of trees over a vast area. Despite being more than 60 years later, the tree line which this tsunami reached is still visible today, which extends across much of the fjord. Unlike many other tall tsunamis, the earthquake which caused this disaster was not a megathrust quake with significant vertical ground movement. Rather, the large magnitude quake caused mostly horizontal motion of the fault line, which was insufficient to generate the towering tsunami. Instead, this event was triggered by a powerful landslide, which when combined with the area's shallow water E-shaped profile allowed for towering waves to slosh back and forth like in a bathtub. The landslide in question originated on the eastern side of the bay adjacent to the Lituya cause of the tsunami glacier. There, a highly steepened section of an existing mountain was uplifted by several feet, causing a critical point to be reached which generated slope failure. 31 million cubic meters of rock then quickly dropped off the near vertical cliff as a massive chunk of material, falling to the water which was 2,000 feet below. This material partially struck the water but also a section of the Lituya glacier, causing the end of the ice sheet to shatter and fragmenting more than 100 feet thick of sediment underneath it. As water was injected into the bottom of the glacier, more than 200 million cubic meters of sediment slid deeper into the bay, as part of what is known as a dual landslide. Combined, these two landslides contained about 0.23 cubic kilometers of rock, whose displacement of water was sufficient enough to generate the towering megatsunami. Since the landslide moved in a westward direction, the highest point of the tsunami was at a cliff face directly west of its origin. However, I would not recommend visiting this location anytime soon to see the damage firsthand. This tsunami, although extreme, was not an isolated event. Looking around the site of the 1958 landslide, 5 other young-looking collapse scars can be seen in the landscape. The aftermath of several of these tsunamis was recorded by explorers, the earliest account previous megatsunamis of which noted tree damage identical to that seen after the 1958 tsunami in 1786. Later explorers noted 2 other lines of dead trees, representing 2 prior megatsunamis that occurred between 1854 and 1916. A subsequent megatsunami was witnessed in 1936, with wave heights observed to be 150 meters or 492 feet tall. Thus, it appears that more such tsunamis will occur in the future. The odds of another megatsunami occurring in any given year is about 1 in 50, and there truly would not be a way to predict a landslide in advance. The 2 mountainsides highlighted on screen are highly structurally unstable, and a future landslide does not necessarily need a trigger such as a major earthquake to occur. Tarn Fjord megatsunami. As a final note, I want to add that Lituya Bay is not the only location in Alaska to generate a megatsunami. Another example occurred in the uninhabited Tarn Fjord when a 76 million cubic meter section of an oversteepened mountain collapsed, generating a megatsunami of up to 193 meters or 633 feet in height. This tsunami was not triggered by an earthquake but rather long-term instability. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank my new patron Parker Smits for supporting this channel.